this presentation. Why do we call it that? You know what I'm saying? Like, I have some music up in here, remix it, what we doing? Well, Enqi specifically is going to be going into an antioxidant pathway called the NFR2 pathway. And it's coupled with another protein that's called DJ1. So I thought it'd just be cool to call it DJ1. You know what I'm saying? So I need my say uses. But we gotta go step by step first in order to get there. That's later. Alright. So how many people are got body courses, got complex course? Yes? Yes? Not yet. Not yet. Okay, so we got some people that got a little foundation. Y'all fresh. Right. No, you're good. We've had some conversation. Look at that skin, boy, you shining. I see you back there. All right, so this is what we're gonna start off with. Most of the time when we think about atoms, because that's basic unit, right? Of course it goes smaller. Gets smaller. But we all usually start with the atom. Now this representation of the atom right here is actually not what it is. Okay, we always thought there's a nucleus, and the nucleus contains what? Please project. Okay. I'll get there. We here all day, huh?
We want to record everything, so
everything.
We don't want to have zero volume for the first hour. And then
oh no! You'll be surprised how loud. I
want you to talk to these people the way you talk in the house.
In the house?
Yeah.
I'll get there. I gotta get there. Okay. Now, what's the core?
DNA.
No, I said atom.
Oh, an atom.
Come on, bro.
Oh, an electron.
Yes, atom.
I'm sure I thought it was a cell.
No. I said basic unit. Atom.
Energy.
The nucleus is what?
A proton or electron? A proton. Neutron.
Proton, yes. See, this is why I started with this. Because we always jump so far ahead, and folks don't even be there yet.
Right.
So I'm like, we got to make sure everybody's on the same page before we even get to NFR2. Like, they ain't going to know. All right. So, proton, yes. What else? Yes. All right, where's the electron at?
On the outer ring.
On the outer ring. What are the outer rings called? What are these things called?
Valence.
Valence or orbitals. Okay? Electron orbit. All right, so I got it up here like this just for simplification. Okay? And I'm going to show you what they really look like after we get the basic thing down. All right? All right. So, all right. So proton and neutron represents the core. Electron represents the peripheral. Okay, and that's like anything in life. I usually use Uber as an example. Most people don't know the Uber sign is like, I think that's it. Something like that. And it's deep because that's the circumpoint, which is a rod symbol. You know what I'm saying? That would circle around. Because Uber's whole thing is they want to be able to take you wherever you need to go. You see what I'm saying? So that's why they have the circumpoint as their logo. So electrons represent that same thing. It represents the periphery outside wall. The inner represents the core, represents the nucleus. Now when we're talking about energy, it depends on where this electron's at. The inner orbital is going to be its low state, and if it can hop up to this state right here, that's a higher energy level. And whenever electrons go from one level to another, there's energy involved. And most often than not, that energy can come in the form of photons of light. So when you deal with stones that glow, I was talking about these stones that Master Enqi talks about. They're called gaming zoo. They're kind of like the infinity gems from Avengers. They're like purple, they're green, they're blue, and they glow on their own. And the reason why they glow is because the rare earth minerals that make that stone up, they're constantly doing this right here. And in that, photons is always escaping. And if a photon escapes, you recognize that photon escaping in the terms of being a certain light, a certain color. So you see blue, you see purple, you see green, things like that. All right, so that's the basic. Oh, and I forgot the main part. What are the charges of the 3 subatomic particles?
Positive, negative.
Which is which though?
Proton, positive, electron, negative, and neutron.
There you go. And when you look at science, everything falls under that category, whether it's acid or alkaline. You know what I'm saying? Everything is always plus, minus, and something in the middle. You see what I mean? Or something to rotate around. Now, let's take a carbon atom and make a carbon molecule such as benzene, right? So, benzene, right? 6-sided, right? And anytime you see a 6-sided geometrical figure, even though there's nothing written on here, you automatically know that each one of these corners are what? What do these corners represent? What element?
Carbon.
Yes. Yes. It's inferred. You don't have to write them in. Anytime you see any type of molecule and there's a corner or the end of a line, the end of the line or that corner is always carbon. They're never going to put a C. They're always going to put an N for nitrogen. You know, hydrogens are inferred too. Like, these are automatically hydrogens because in your body, if there's a carbon chain, anything, hydrogen is going to be bonded to it because everything is submerged in water. You know what I'm saying? All right. So we know that all those corners represent carbon. So now, that picture was really us looking like at a bird's eye view. It's really a plane. It's how you sit in the seat, it's a plane. So you could really do it more like, so this is facing you, and that's going to the back. You see what I'm saying? This is the back going this way. This is going this way, like this is a tabletop. Okay? And each one of these corners, like you said, is carbon, right? Now, how the electron orbitals and valences actually look, they look like dumbbells. All right? So from each corner, first I'm gonna draw a line. Guys, I draw one up here, one up there, one up there, one up there, one up there, right? And then there's one below it too, below the plane, right? So then I do like this upside down teardrop. This means it's underneath the table. Underneath. Right? So, what do these dumbbells mean? Well, electrons, they don't really have a direction, velocity, or anything. What these clouds stand for is the probability of any point they can be in space at any given time. It's just that they're confined to these regions. Okay, so imagine these are little balloons that got blown up. And in a balloon, the reason why it's inflated is because it's filled with air. So at any part within inside that balloon, in the balloon, on the surface of the balloon, that's where the electron could be at any given moment. And because it moves so quickly and it's unpredictable, this just represents the volume of probability of the electron. Okay? So this is what it really looks like. And then you got different orbitals. You got like the sp orbital, which is the basic circle. Then you get into the p orbitals, which are these, right? Then you get into even more orbitals. Them things, they start getting funky shapes, like they get wild. But all of those different shapes is what constitutes the geometry and everything that gets built up in our reality. We ain't gonna go there. We're just gonna keep it here right now. All right. So when you're dealing with a benzene ring, the interesting part about it is there's 3 double bonds on there. Okay, that's a double bond. That's a double bond. That's a double bond. All right. So that means this is a double bond right here. That means this is a double bond right here, and that means that's a double bond right there. Now, the interesting thing that happens when there's a double bond is these two, which they call pi orbitals, they end up forming something called a pi electron. All right, and a pi electron forms an arch. Y'all ever seen Tesla turn on any of his machines and he got the 2 balls, the 2 metal balls, and the electricity arches over? Same thing. Same thing. Matter of fact, this benzene ring was a vision that a chemist got. His name is Enqi, and he called it the Ouroboros. Y'all ever heard of the Ouroboros before? What's the Ouroboros?
And like there's light in the sky, right?
No, that's the Aurora Borealis. Aurora Borealis. You know,
I think that's where
Aurora-
the snake comes.
snake eating its own tail. That's right. Ouroboros, snake eating its own tail. That's what that means. Current cycle, right? So he had a vision of a snake eating its own tail, and he was like, that's it. I understand benzene. And he was like, yo, this is what's going on. Electrons get delocalized. When they get delocalized, they end up making a circuit. Let me explain what I mean by that. So everywhere there's a double bond, you're going to get this arch. Right? There's a double bond here. So these two, they're going to connect. They're going to make an arch. And then there's another one back there. They're going to arch. Okay, so now you've got these 3 arches. Yang, 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 yang. Now remember, this is just one molecule in the body now. Okay? One molecule. This ain't a protein yet. This ain't tissue yet. Bones, body, nothing. We still microscopic. Okay? So if all this is just going on with this little thing that I'm showing you, then that lets you know how much power is being generated all the time. Okay? Now this is also known as a photon trap. Okay? Photon trap. What does that mean? That means that exactly what it says. It traps photons. It's able to, it's a, you would call it a chromophore. Chromophores are molecules that have the ability to absorb light. Hold the light though. See, the thing about light is it can dissipate, it can lose its energy. But you want to find a way to keep light on its highest state consistently. You know what I mean? And that's what photon traps do. All right, so you got these arches. Now what happens is, once these arches start up, they start flipping. So first you see these 3, right? Boom, boom, boom. Then it changes. And now it's this one, and that one. Right? And then they arch, and then it flips back. But it's going to speed of light. So what happens? They start flipping so much that they become delocalized. What does delocalized mean? Huh? What does delocalized mean? Delocalized. Because what is it?
Where it's located?
Right. If localized means that you're in a certain space, a certain area, that's who you are, that's your coordinates, then delocalized means you're not there no more. So delocalized means that those electrons are not just confined to those little bubble spaces no more. They're more in an open area, and I'll show you what the open area is. So instead of them being the dumbbells, now it's this. So they became delocalized. Now you got a circuit of energy. Yang, 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 yang. All this is going on in this one molecule, just one. And you're gonna find out where this molecule is found all over your body all the time. You see what I'm saying? So just one unit does this, and what do they do in concert, right? All right, so
Quick question.
yes.
The demobilization you're talking about, is that constantly happening, moving back and forth?
Oh yeah.
So is that alternating current?
Well, when they arching, they're flipping. But after they go through that flip mode, then they delocalize, and it ain't a flip no more. Now it's just a circuit.
Okay.
Because they done went so fast. You know, almost like if you look at a video, they showed us on Lucy, you see a video of a car driving by, you fast forward it fast enough, eventually you ain't even gonna see the car no more. Because it's moving that quickly. So that's what's happening. It's getting so fast and it's at such a speed now, it turns into its own circuit. Alright? So it's almost like we see wires and we know current goes through the copper, it goes through that. But what if we was able to pull the current out? That thing was just able to see that thing. You know what I mean? It has this energy just flowing. Now, anytime you have a current moving in a certain direction, like if current is going this way, what else is created based on electric current being created?
Magnetism.
Magnetism. Now, what direction is the if this is going like that, then which way is opposite?
This is based on right hand move.
It's right here. Doing
Something
either way.
like
But
this.
yeah, it's perpendicular. But no, I'm saying, you see which way this going.
Right.
So which way is the magnetic field going? Up. Alright? So now you got this magnetic field going on. Alright? So you got a magnetic field, and now you got a current. This is what's really popping. Okay? Melanin is made up of these units. Your DNA is made up of these units. You find them everywhere. Alright? All right. So now, we got that understanding. Any questions based on that first little part right there? Peace, Queen. How are you? What's your name? Courtney. Okay, Courtney has joined on in. All right, Courtney, just to bring you up to speed real quick. I just explained, I started with the atom.
Yes, so had to keep the lecture noise-free zone. So when you have a triple space, it kind of works out. You do the lecture all the way over there, and then do the family thing, and because these people feel entitled So they go into the lecture, sit down for 5 minutes, and then start walking behind the counter. They're in the back, they're in the fridge, they're looking for seconds, thirds, fourths. Like it gets crazy. So, yeah, you probably know all these people.
Everybody say hi.
Hi, camera.
Hey, there you go. You got wave to the camera. Right. There we go. Wave to the camera. There you go. Yeah. Yay. How has life been back here with the kids?
It's been awesome. We've been doing hair and having fun and playing.
Oh yeah, you got the hair out the way. You've been wanting. You gotta make sure the hair's done. Yep.
Yes.
You got this, man. Come on, tell him you got it.
He got
Show
his
him
own
those.
bench over there in the corner. That's what they on.
Show him the muscles. Show him the muscles. Ah, there it is.
Show him the 6-pack.
Uh-oh. Ooh. Muscles. Muscles.
No, I'm holding it right here so that Kylie can't go.
Muscles. Muscles.
Just wanted to start with some basics to see where people were at with things. All right, so that's that. So let's go to the next part. In terms of our energy, in terms of our day-by-day, our existence, we have to keep on providing our body with fuel and energy to perpetuate ourselves, right? What is our main source of fuel? Where do we get the majority of our energy from? There's no trick questions, y'all. Exactly. Light, sun.
They are all trick questions, y'all. Don't listen to KC.
So much so that when we look at our requirements of energy, light represents 2/3 of our energy needs, while food only represents 1/3.
And even in that, food is basically like
It's secondhand. It's secondhand. So you could get cash or you could get a check. Right? Cash, you get, bet. You can spend it. Check, you gotta go to the bank, stand in line, show your ID, sign the joint, count it out.
Then they take some of it out.
Hey, that's digestion.
right.
That's eating food. You know what I'm saying? But if you know your bank and you know the times, you know what I mean?
Right.
And all that type of stuff, you know, you get there, slide on in, get your money, get out, and it's really nothing. You see what I'm saying? And digestion could be a thing where you could really get some good stuff out of it, but really the requirement is sunlight. You know, Enqi made it a big thing, screwing in the earth, getting up in the morning, first light, all that stuff is so important. You know what I mean? It's tantamount. All right, now, when we talk about digestion, all right, that'll work, right? I don't know what that is, right? Is that good enough for you? Okay. All right, so when we eat food, it's very important that the food we eat somehow relates to the environment that we're in. Why is that? Anybody? Why is the food we eat so important in regards to the environment that we live in? Like fair trade, local, you go down to the market, they like the zucchini we just grew. Why is it so important to get that food?
Because that food knows the pathogens or whatever is going on in that environment that can help you realize the food or your body or whatever you eat.
That's good. That's good. That's good thinking.
Yes.
I was thinking, trying to put it together. Something with, say, bacteria, they do it down on something in the environment in your stomach,
Right.
and food in that area specific for trying to connect this in kind of way.
That's right. No.
Pieces together.
Vegan.
Okay.
No, you're going in the right direction. You're going in the right direction. Okay. Microbiome. Okay, what is the microbiome? 100 trillion. It's a lot, a whole lot of microbes inside this boy right here. Now, why are they there? They're there because you don't eat food for food. You eat food for light. But what light is it? What light is in food?
Sugar, photon.
No. Sunlight. Sunlight. Now, is Florida sunlight the same as New York sunlight?
No.
How about California and Texas? How about Chicago and Hawaii? So that means if I grow food in Florida, then Florida food got Florida sun in it. And New York got New York sun in it, right? What these bacteria are able to do is when you digest that food, they're sensors, they're able to tell where that light came from. So if it's the dead of winter and you eat a mango, it ain't gonna match up. But if you eat like a winter squash, butternut or something like that, yeah, you get with that. Especially if it was grown in the area. You see what I'm saying? And then the other thing that matters is deuterium, which is a heavy form of water. You see, like depending upon where food's grown, it's going to depend upon what type of water that plant used to make that food. And all that info is in the plant. The food ain't nothing but a container of coded info for these guys, so that they can convert that stuff into a more assimilated form and it gets absorbed in your body the way we use it. Okay? So, that was an introduction into one of the main topics.
Okay, I don't want to go off topic. Can I ask you a question?
Yeah.
Okay, so.
We
even if it's
fans,
not-
we up
even
in
if it's
here.
not organic,
Huh?
even if it's not organic, can we still, it's still better to get the locally grown food,
That's right.
even if it's not organic?
Yeah, because you got farmers, like you got D-Town farms, and they don't grow everything organic, but they ain't using a bunch of junk either.
Okay.
Like the organic signs is just because you don't know where you're getting your stuff from, you don't know what they're using. But if you know your farmers, if you know the people that are growing this stuff, and you know they ain't putting stuff on it, then that's organic. I mean, organic
That's what
technically
I said.
means it's carbon. That's what organic technically means. But now it means a certain standard of growing foods. But that's because we get foods from all over the place, and we're not there to see it through the process of growing. So I would urge everybody to get in touch with D-Town Farms and get in touch with the Hoys over on Church Street, all the community gardens. That's the thing about Detroit. Detroit got so many people growing stuff. You know what I'm saying? And you need to get involved with these people. Go down to Eastern Market, start walking up to these farmers. There's this one brother, he always got the watermelons. He got the best watermelons every time. You know what I'm saying? Holla at that dude. Find out where he at, where he growing, and get your stuff in there. Oh, y'all from DC? Okay, well, y'all got farmers. Y'all got farmers.
Marlboro Pike that be, have all this stuff.
Y'all got like go holla. And they're gonna love that you hollering at them. They just be sitting around waiting for people to engage
Right,
with
with the
them.
sun beaming on it and
Do
everything.
you know how much work farmers go through, bro? They producing that yield to come out just so we, 25 cents a pound, $1.99. Like, they hardly make anything. Like it should be Gucci prices for that type of work. You know what I mean? So much.
It's time to eat. Now, if you notice, I don't use oil. Everybody is over oiled out. If you're making these vegan meats, right? First of all, these are transitional, so your diet shouldn't be primarily composed of these. But if you're making these, don't do yourself dirty. Okay, remember, oil has a smoke point. Past the smoke point, every oil is rancid. Period. Doesn't matter if it's coconut, olive, whatever. So when you're doing this, look at these. Go close in on these so they can see. Look at this. Why would you need to add oil to something that has its oil already in there? This is how you lower the amount of oil you consume by letting the stuff that you're cooking create its own oil. And what I put on top of this is just water. So I'm actually getting rid of some of the unnecessary oils by not adding oil, using water and letting the water drain out the excess oils. You still get the no stick to the pan, you still get the same taste, still good, you don't need oil. Oh, all right, catch it. So this is what I'm talking about. So the excess oil, this is what you do with that. Let that run off. Let that run right off. Because of this, it's going to just drain. Same taste, no oil. You don't need excess oil. Even after like 4 or 5 rinses with the water, you still see all this oil. Look at this, come on this side. So that way you can really see. Look at all this oil, all this grease. Why the hell would somebody need to add more oil to this? No. The name of the game is getting rid of this motherfucking oil. A lot of times we're putting an emphasis on the wrong shit. Sugar, salt, oil. You got to figure out how to control those in our cooking. Because if we go by the tongue, we always gonna be lost because oil hides sugar and salt. So that's why they play that game with the salt and sugar with the flavoring. Your body's gonna get every bit of it, but your tongue ain't gonna pick it up. So they play mind games literally with your taste buds. And you notice once the water, like once the oil is washed off, I didn't change the temperature, but you see it cools down, kind of dissipates some of the heat. So a lot of people like to rely on no-stick technology when you don't need to rely on no-stick technology. What you do need to do is stand over top of your food and monitor it. Like people want to be able to put shit on and bounce. You know what I'm saying? Oh yeah, well, I ain't even gonna call out a certain person. You know what I'm talking about. Your pans be sticking. No, they don't stick when I use them because, you know, I'm standing over them. Yeah.
Alright, so microbiome. Alright? Before I dive deep into what microbiome is all about, we gotta do a prerequisite, and that is we have to get an understanding of this word. What does that say? Pleomorphism. Anybody know what that is?
About how it's a study of how we effect or can cause disease in our body or something.
It's connected to that, definitely.
It's how it's whether you create, whether diseases come from outside or inside the body as juxtaposed to does your body do they start inside your body as opposed to outside?
Right, okay, so you got this guy here. Okay, and then you got this guy here. Alright? And just like Mortal Kombat and Street Fighter, fight! They was at war back in the late 1800s. Okay? Now, this dude right here ended up getting backed or endorsed by these guys. Just gonna do a good style Rockefellers. Right? So he got backed by him. He didn't get backed by nobody. Usually the people that speak the truth don't get backed. Alright? Now, what was the war? Well, the war was, he believed in pleomorphism. He believed that the maloo, the mixture, the chemistry of the body is what determines what happens in the body. You know, food you eat, the environment you live in, you know, all those play factors. And based upon how harsh and how aggressive those things are will determine what's going to happen inside your system. All right? He was like, no. The body is completely sterile. Completely sterile. Like you got red blood cells, you got hormones, you got all that stuff, but you know, no yeast belong there, no bacteria belong there. You know what I mean? No viruses belong there, none of that. It's a sterile body. And everything outside of you is dying to get up in there. And the minute they get in there, it'll take over, it'll infect you. And in order to off do this infection, we need to shoot inside of you that same stuff so you could get an immunity and then it can't hurt you. Right? That was his pitch. So his last name is the root word of what?
That's right.
You know what I'm saying? Vaccinations, all that stuff came out of him. But they financed him. Why did they finance him? What Edison do? Because there was another war. Remember, it was Edison and Nikola Tesla. Right? What did Edison do? What is he known for? Okay, so if I got electricity and light bulbs, what I need with lamps and lanterns?
Right.
So this guy, who was what? What did he produce?
Oil.
Oil,
Yeah.
petroleum.
Exactly.
You don't need oil and petroleum when you got electricity now.
Right.
So when he gets shut down, he's like, I got all this oil.
Yeah.
What am I about to do with it? Well, hydrocarbons and all that stuff, when you rearrange all those molecules, you can make synthetic versions of a lot of stuff. So that's what he got into. So they got together along with some other guys, and that big pharma, all that stuff, hospitals, came out of this. And this guy got rolled on because he didn't have the backing. You know, we're talking about posters. Just like now, if Instagram is a poster, the jingle every time you went on it, a commercial on the TV, you got the plane flying over with the long sign in the sky, the blimp with the neon, like that's how he was getting down. And then it was real, it was sensationalism. You know what I mean? Like the preacher in the church. So everybody fell in line. And the reality, our matrix, right? Not the real world, but the coded matrix that we live in is based on his code. So our understanding of health and our body and everything is because Hitler won. You see what I'm saying? And now Nazis is everywhere. We think Nazis is normal because that's all we know. We didn't even know about him and everybody that came before him. All right? So, pleomorphism, many forms,
Can you kind of go over the basic definition again?
many forms. Because morphism means to change, and pleo means many and different. So to change into many different forms. Because poly can mean three or more. So it's not polymorph. Alright, so you got right, you got your so you got your virus, right? You got your bacteria, and then you got your fungus. Your fungus be looking like kind of like flowers. So inside of every one of us, every mammal, exists this small unit of life. Okay? And over the centuries, it's gone by different names. Some people called it somatids. Alright? Some people called it endobionts. Currently now in science, they refer to it as refringent particles. Because refringent means that it's giving off light and they're small little particles, so they call it that. Because when they look through the microscope, they be shiny little particles. If I went into Kemet and I pulled out a mummy, and I was to put its flesh in water, or ground its flesh up in a powder and put it in water, there'll be a bunch of them in there, wiggling around. Now, they have their own little cycle, and they have a three-stage cycle, okay? 3 stages, where it's like, it's its basic form, then it multiplies, right? And then it goes back to its basic form. If your acidity in your body increases or your pH drops, they mean the same thing. Then what it does is it passes the 3rd stage and then it goes to a 4th through 16th stage. And those 4th through 16th stages are them. So when people have cancers and viral infections and whatever pathologies, multiple sclerosis, all these things are self-induced. And it's the food, it's the environment, it's the relationships, it's a combination of things that ends up taking this little particle of life and pretty much just letting him do what it was made to do. Because we make the mistake in sickness and disease. Sickness and disease is not a bad thing, it's really your body doing its job, right? Because you told these somatids through your actions and intent, I don't want to be here. I appreciate the earth, it's been fun, but I think I'm good now. So it'd be like, bet.
Break it down.
You took that loan from mama, your body, you ain't taking that where you going, so I gotta take that back to the earth. So it starts breaking you down, decomposing you. And most diseases is decomposing matter, things breaking down, catabolism. You know what I'm saying? Or catabolism, rather. All right? So whether you're talking about herpes, whether you're talking about GERD or inflammatory bowel syndrome, whether you're talking about candida, there's a certain level of candida in your mucous membrane. It don't mess with you. It don't do nothing to you until it starts overpopulating. But that's like anything. Think of your body like Detroit, like a city. Detroit has its own neighborhoods. These people live over here, these people live over there. You got downtown, you got Belle Isle. Each one of them got different people with states of mind. They have a certain way they live. Now, if one neighborhood increases, that increase in population in that one neighborhood will affect the whole city. Because their mentality, their thought cloud will become predominant. And then they're gonna want more room because they're growing. They like, we growing, y'all need all that. So they start strong arm. So that's how you change the mood in your body, just by messing up the balance. So like I said, in your gut, you got 100 trillion. That's a lot. There's only, what, 7, 8 trillion they say on the planet? But there's 100 trillion bacteria in your gut. They're not all the same. We're talking about 25 to 30 different species. And each one got their own percentile. And when you change the percentile, or you wipe one of them out, when you decrease diversification, meaning now you don't have 25, 30 different nations living together, you got like 3, that's when you sick. That's when you sick. It's the microbiome. You see, it's the bacteria that gets induced by the way you eating and the way you living. Theomorphism. All right. So let's say I eat some kale, right? Give me a little bit of kale. Boom. Out of this kale, one of the main things they say I'm gonna get vitamin K. Right. Now, what's so important about vitamin K? Anybody know what vitamin K is good for?
Cloudy of the blood.
There you go, yes. Hey man, y'all about to get some spankings in here. You told me that you got body course. You said it too.
Oh,
You know what I'm saying?
I knew
I
was waiting it out.
You know, you're letting everybody else get it in first, you know. Clotting looks like clothing. But yes, clotting or coagulation of blood. You know what I mean? You cut yourself, you need it to coagulate. If you have a blood thinner, if you put garlic on that, you bleeding out. It ain't never gonna heal. Okay? Now, another thing about vitamin K is the fact that it is one step from becoming vitamin K2. And what vitamin K2 and vitamin K are they're plant analogs of CoQ10. Anybody know what CoQ10 is? It does when it's on its own, but what is its main function? What is it known for? What is CoQ10 known for?
I think it like regulates the heart rate.
Oh, skin. This is one of the most important. So what is this?
Mitochondria.
Okay. Try to draw this out, y'all. This is what it is. Out of this drawer. Yes. Okay, so the mitochondria is double membrane, right? Outer membrane, a space in between, right? This is the outer, this is the space in between, this is the inner membrane. And in this inner membrane, you have 5 complexes. I'm not putting the ATP synthase in this one, I'm just talking about the transport chain, which is 4. These are the 4 complexes. When you have your citric acid cycle, right? You know, with me on the citric acid cycle, I'm not gonna assume anybody knows anything. That's why we here all day. Because I'm dealing with basic, I'm going deep through it all. Because I can't go in if folks don't really get the simple stuff. So if you don't know, don't feel no way about it, please be like,
Oh, I don't.
what the hell?
I don't know any of it.
That's good.
Right.
Thank you. Thank you. So
I'm just
as I'm
learning.
speaking,
Right.
don't let me advance if you don't get it.
I
Don't.
catch on. That's the thing. So I just.
That's cool. Then that's your personal choice.
Right.
But if you sit there and you're like,
Oh no, I'm a
yes. Okay? Alright, so citric acid cycle is the cycle that occurs in order to liberate energy from glucose. So when you eat food that has sugars inside, you eat an apple, chew it up, get it in, and it gets inside the blood and all that, gets inside the cell. You want to perform glycolysis first, which is a process where you break sugar down, right? And then from that part, after the sugar gets broken down, it enters into a cycle called a citric acid cycle. And through the citric acid cycle, this molecule gets rearranged so many different times to yield carbon dioxide as a byproduct, water as a byproduct, but most importantly, electrons and protons, because that's what we run off of. We run off of hydrogen and we run off of protons. Yes.
Okay, great. So that's tight. So we were just talking about that, doing cleanses and stuff, but you eat garbage, you know what I'm saying? So it's like, you have to do the cleanse before you start eating the better foods, right? Because if you eat sugars, fake sugars, the body don't really recognize it, and they do some other stuff.
Oh, we recognize it.
It recognizes
Just not
it,
for
it
the
does
good,
some
right?
it
It'd
does
be
some
like
other stuff.
toxicity alert.
Right, it
Yeah.
does some other stuff. It does the same thing, but it's like fake. So I guess
Yeah,
it's
no,
like
it don't do
garbage.
the same thing. It just tears you up because it's not real sugar. It's not a simple sugar. It's been manipulated. Sugar's not a white crystal. That's not what it's supposed to
Right.
be. You know, they actually run sugar through animal bones and fish bladders and stuff
Yeah,
like that in
weird.
order to get that
Right,
clean white.
It get real weird. So
Yeah,
when
and then
that-
it comes from beets. All the sugar are beets. Yeah, it's not sugar cane no more. It's beets. Beets got a lot of sugar.
Really?
Oh my goodness, yeah. Carrots too. Carrots got a lot too.
Okay. So
Alright.
what I was getting to, with that being said, if you just stop eating the junk and you start eating the better sugar like fruits and stuff like that, will your body cooperate right away, or will it take months before it gets to?
Oh, it's gonna recognize that immediately.
Okay.
Yeah,
Alright.
yeah.
I didn't know. I was just wondering if there's like this like limbo time period of switching from cookies.
Well,
and stuff
depending,
to-
everybody's different because people have different states of pathology
Okay.
that they're stuck in. And, you know, if I'm not dealing with that much, but you're dealing with a whole lot more, I start, you know, drinking juicing and eating certain things, and you do too. I might benefit from it a little bit quicker than you, but you might have a more profound effect than I do. It just takes a little bit longer because it's dealing with more stuff,
Okay.
you know? So after it goes through that cycle where it's releasing electrons, you have electron carriers. The reason why you have electron carriers is because, for instance, if I light a match, right? And I hand you the match, and I say, pass the match around the room, right? By the time I get the match back, it's not lit no more. What if I had a carrier where I could put the match in, and when I pass it to him, it keeps the flame going. So when I get it back, it never even burnt down the stick a centimeter. Like, it's still in the same spot. This is what electron carriers do. They're able to carry electrons without the electron being compromised, because our body is popping. Like, it can lose energy in any corner because everything's looking for, just like the street. Everybody's on the grind. They're looking for an opportunity, and if you fresh meat, you gonna get ate up out there. You know what I'm saying?
So even if someone's really sick, their body still has
The potential.
Yeah.
Yes.
Okay. I just because people
Yes.
be making it seem like they can't do it.
Let
So
me-
I'm like, nah. I think you should
Look,
just, okay.
you're made up of 75 trillion cells. Then each one of your cells have 10 bacteria per. So you have hundreds of trillions of bacteria. Each one of them 75 trillion cells have DNA. Each one of them bacteria got a genome. You telling me all that bacteria, all that DNA, enough DNA to go from here to the sun and back 300 times, 600 times, and you telling me you get some lupus and you can't get rid of that? What is a lupus? I'm like, yo, if lupus needs a shrine, then AIDS need a shrine. We need to be praying. We need the church of lupus, because it's that bad that I can't get over it. I can't get past it. You know what I'm saying? So once that electron carrier that's able to preserve the electron, it brings it over to the mitochondria to this first complex called NADH.
What's the name of the electron carrier?
NADH.
Okay.
Nicotinamide adenine dinucleotide. And this
Say that one more time.
nicotinamide adenine dinucleotide. NAD, and the H represents the hydrogen. And what these are reducers. Okay? Now, we're gonna get there, but I guess I can just say it now since it came up. But redox is an abbreviation for oxidation
Let's mention the settings.
and reduction.
Hey, KT,
Yes.
you got about 2 hours still.
Yeah, no, I ain't even got in the DJ and none of that DNA.
Right.
I'm just all up in here.
I just heard you say something with a time reference, so I'm like, it's supposed to.
No, I said I had time.
Oh, okay, good.
No, you got 2 hours, bro. I don't even know what to do because I never have this much time to just do my
Technically,
thing.
there's no rule saying we gotta leave at 7.
No, we can stay till 7 tomorrow if we want to. So, redox is a combination of red and ox. Okay, the red is for the reduction, and the ox is for oxidation. Okay, and what oxidation and reduction means is the giving and receiving of electrons. Okay, so reduction is what?
Adding. Oh no, when you gain electron.
And oxidation is
Losing.
right. A good mnemonic is what? To remember.
Oil rig.
Oil rig. Oil rig. Why oil rig? Because OIL stands for oxidation is loss of electrons. Reduction is gain of electrons. That's how you always remember that. So all these enzymes, they call them reductases. Anything with ace at the ends means it's an enzyme. And if it's a reductase, then that means it's an enzyme that reduces. All right, so this NADH gets oxidized, right? Because it's losing an electron and it's giving it to him. And as it gives it to him, it gets oxidized, it gets reduced. This little electron is in here. Now, this part of the mitochondria below this membrane is the matrix. Well, that's nothing. These folds is called Christ. They're called Christae. Cristae. Christ matrix. Oh, that's nothing. Like I did an event last night and I talked about a protein called nectarin. And the root word is nectar. Not because I saw it, because the definitions say that comes from the root nectar, which means they use all the terms. There's a amun protein, like the whole chemetic thing, pantheon is all in microbiology, and that's essentially, I'm not even gonna get to that because that's what his book about to be about, so I ain't about to blow him up. All right, go. We gotta get this word first though. All right, so who's familiar with the electron transport chain in here?
I am.
You focus on that stupid burger you're making back there, man. You about to make the silly burger for y'all. Okay. Okay, nobody. Good. All right. This matrix area has electrons, okay, and protons in here, okay? They're all in this gel. Now, this membrane, solid line in between the enzymes, is semi-permeable. Semi-permeable means that only certain things can get through it. One of the things that cannot get through it are protons. They are not allowed from this side to go into here. They can't do that. However, when this electron gets donated and this particular enzyme receives this electron, because protons and electrons have such an affinity for one another, because that's what an atom is, right? Like, it's difficult to rip an electron off from the nucleus. This is looking for this all the time, so they can be stable again. So as this electron gets donated in this enzyme and it starts flowing through it to go through this membrane, these protons sense that electron in there and they're like, whoa, like magnetism, and it pulls it, and because it can't go through here, it uses the enzyme as a doorway. So this goes through here and now it's in the intermembrane space. As this electron keeps going through the different complexes, they all pump protons into this space. So now this area becomes supercharged with protons. Matter of fact, so much so that it becomes imbalanced and there's none but protons up here and there's nothing but negatives here. So we got a battery now. Because anytime you have a concentration gradient, a split of charge like that with a film, with a membrane, you got a battery. Okay? Now, I got into all of this because we was talking about vitamin K. Right? You see how much the body is? All that just to get the vitamin K, right? So that vitamin K2 or that CoQ10 is also known as ubiquinone and ubiquinol, which they got two names because one is the oxidized form, one is the reduced form. They're electron carriers, okay? And what they do is they're like this is a membrane, this is fat. Anywhere there's fat, there can be no water, right? What happens if you sauteing some in the pan, you throw some water in there?
Oh.
It's gonna pop you, right? I'm like, water don't like oil so much. If you throw it in the pan, it will jump back out of the pan. You know what I'm saying? Like, what the hell projects that shit all the way out the pan back on you like that? Like, that's something serious. That's some serious energy. Okay? So this ubiquinone has the ability to tunnel through the fat right here. Tunnel through the membrane. All right? And as it tunnels through, it carries this electron on to the next complex. Okay? And then they come in here. So, if vitamin K is the plant analog of this, and this is the main way you get your energy, then that means that vitamin K must be real important. But see, it's not so much K, but it's the K2 that's really like the ubiquinone. Like almost like it's the same damn thing. And how you go from K to K2 is in the microbiome. Because the microbes in your gut, when they consume that, they convert it to K2. So now you have a CoQ10 factory in your gut. And it's going to go straight to the mitochondria, and now you have a way to cycle electrons a lot quicker. Okay? Now, these pluses, they build up, man. They build up. They build up. They build up. It gets thick up in here. Now, what do you think happens when all this stuff builds up? What do you think the protons want to do? What do you think they want to do? What do you think all the protons want to do? They building up. Let's just say you're filling up an air mattress and it is finally full. but the air is still on. What's gonna happen with the mattress? Right, because what does that air want to do? It wants to escape. But it can't, because this is semi-permeable, this is semi-permeable, and it's not going to let hydrogen ions go through it. It's just stuck in there. It's like, we got to go. So that's where the fifth complex comes in, which is ATP synthase, and it's a turbine. You know the turbines that's on the bottom of planes? You have turbines. Except the one on the planes get fed air, and through the flow of air, it causes the transfer of the flow into energy and motion, right? In this case, it's hydrogen flowing through the turbine, making it spin 1,500 times a second. The only reason why it's so unattainable for you to grasp is because we don't consider scale. And if we shrink down to quantum level, it's different time there. There, a second might be more like 2 weeks. You know what I'm saying? But up here, it's different. That's why a fly looks at us in slow motion when we're trying to swat it. It's like, there's nothing. He wait till you like right here. You know what I'm saying? And then he bounces. Like, no, you just get madder and madder and madder, right? So these want to get back in there, and they get back in there through the ATP synthase. So like I said before, anything that spins, right, induces a magnetic field. So a lot of your magnetic field comes from what? Comes from the thousands and millions and trillions of mitochondria you got in your body. They're working right now. They're always spinning, non-stop. Okay? And that's how you get your energy. So the microbiome is able to refine a lot of things that we eat. Why? Because they're from the soil. They're in the rivers. They're in the air. They know that stuff. When it comes in, they can identify. Your cells don't identify. That's not what they're there to do. You see? So it's a relationship. There's a movie coming out in October I can't wait to see. You know, I'm such a big kid. And they did it right, and I can't wait. It's called Venom. I can't wait for that Venom play. Like, that's the first I've ever gotten to beast mode. I was like, yeah, eat his head, bite his head off. Like, it's all crazy. But it's a movie about a symbiote, which is an alien organism that gets with him, and they end up becoming one being. Even though Venom has his own voice, his own mind, and they speak with each other in their head and everything. And the reason why he's known as a symbiote is because Venom gives him powers, and he becomes a host for him. You see what I'm saying? That's what we are. Like, we ain't nothing but a superorganism that contains all types of life. Plant life, fungal life, animal life, we're the totality. So if you can appreciate a solar system that contains planets, that contains different terrains, different animals, and everything like that, and you love life, then why, when we think about stuff going on in our body, we like, ugh? Like, no, you should appreciate all the life forms the same way. Now, if one tribe rises up and we like, we about to take over KT, you know what I'm saying? Anarchy, yeah, then you gotta kind of like put the fire out. But you don't just wash everybody out, you know what I'm saying? Because if you cleanse the microbiome out of your digestive system, you will die. You will die. It'll be a wrap for you, you know? Questions? Oh, wow. Started coming down. Anybody's windows open? It's raining. I guess not. No questions? Okay. Yeah. Okay. What's that? What's that guy right there? Nothing. Nothing. Okay. What are those? Anybody know what these are? Y'all see the letter PPP, right? No. Phosphorus. He went to the summertime party.
Right. See, he was there earlier, and you told him no, Adams.
It's all good. That's why we're here. That's why we're here. That's why we're here. We take it all day. Okay. So, yes, those are phosphorus. How many phosphorus are there? 3. Okay, so now.
I know what it is now.
Yeah.
Adenosine triphosphate.
There we go. Yes. ATP. Adenosine. Triphosphate.
Up top, NHZ or NH2?
NH2.
Okay.
Yeah, NH2. And I think there's supposed to be another N. 1, 2, 3, 4. Now I think that's all there. Alright, so you see, there go that ring. You see what I'm saying? This is a ring too, it's just 5-sided. But see, it has double there. So that same mechanism I was telling you before, this thing's doing that right now. You know what I mean? Alright, so adenosine is a combination of adenine and ribose. What is adenine?
You know that? No.
I actually thought it was.
Oh, it's all good. It's all good.
Like,
There you go. Come on with it. Come on with it. What are they? What are those that you named? What are they? What are those classified as? If you don't know the actual term, just describe it the best you can. What category does those 4 things fall into? No.
Amino acid.
No. No. Nitrogenous bases. These are those things that she was just naming, which we'll be getting into soon, are the steps of the ladder of DNA. Adenine, guanine, cytosine, and thymine, ACTG.
And they don't classify that as amino acids?
No. Nucleotides. You get into nucleic acids when you have a bunch of them, and then a nucleotide is when you have a nitrogenous base, a sugar, and a phosphate.
Oh, okay.
Yeah.
Because it's adenine, guanine.
Cytosine and thymine.
Yeah.
Yeah. Amino acid is gonna have an amine group. Carboxyl and a side chain. Those are the 3 things that make up a protein. Amine group, carboxyl, and then side chain. Those are the amino acids. A lot of the lines get blurred the more you step.
Yeah, right.
They start to. You like, wait. I read this book all over again. Thought I was going somewhere with all this. Or I might sit down and talk with that guy.
Sorry.
No, go ahead.
This is side note question.
No side notes. It's all relative. It's all relative.
Okay, so
Multiverse.
with the double bonds, they spin it and then the magnetism or whatever. They do that, and that's our energy and the whole nine. So when we're lacking energy, Does it mean it's less of them doing it, or they just do it slower?
Slower or less,
Okay.
less or
Is that one of the
leaks,
other? It was
lots
both.
of leaks, because when you get into free radicals, we get in there when we get into the antioxidants and all that. When you get into free radicals, that's what all that is. That's energy. That's entropy. Do y'all know what entropy is?
Yeah.
Thermodynamics.
Anybody? Yeah.
Entropy is Thanos. Okay, and the Avengers represent order, and entropy represents Thanos. Okay, the best way to give you an example of entropy is if I take this chalk, and I smash it on the ground.
It won't turn into a sandcastle.
Right, right. But there is a probability that when it hits the ground, it can form into a sandcastle. Most likely won't. The only way it will turn into a sandcastle is if I am able to understand the trajectory momentum of this
So well.
right, and do whatever I gotta do, create an order, a structure that allows it to form into it.
Right.
You see what I'm saying? That's how you decrease entropy. The increase of entropy is more, I wouldn't even say so much chaos, but like inflammation is like entropy. You see what I'm saying? Because that's the dissipation of energy that would normally be used for structure and orderly pathways to do things, to be very efficient. You see what I'm saying? But every car out here got a muffler and an exhaust pipe because there's waste. I think engines is only like 35% efficient or something like that. Like it's not even a high number. And we're in the 2000s now. You would think there would be some type of engine that would be like 90% efficient by now. But they ain't even that efficient. It's a lot of waste getting kicked out. You see? So fatigue comes from the fact that, yeah, the energy's produced, but it's lost because of the integrity of the whole system. You know, if I got a hole in my pocket and I'm making lots of money and I go home and count and it's $30, I'm like, I know I made like $5 but there was a hole in my pocket.
Right.
Energy don't die, it just transforms, which means somebody found my money and picked it up and paid their bills with it.
But in that case, that energy was turning into free radicals.
Yeah, because I lost all that money. Now I'm in a shitstorm now. I can't pay my bills. I got people following me after me and everything like that. Yeah, that's dangerous. You know, I'm being shot at. Yeah, a bullet is a free radical, bro. Like, it might catch me. Nah, but this is adenosine chalk phosphate. So adenosine represents a combination of the base adenine along with a sugar called ribose. This guy right here is one of the most important sugars you need to know about, because when you're talking about photosynthesis or going way, way back in antiquity, everything got to do with ribose. Matter of fact, in order for you to take RNA, messenger RNA, and turn those instructions into a three-dimensional protein, you have to use a certain organelle. What's the name of that organelle? Ribosomes. See what I'm saying? So adenosine is adenine and ribose. And then tri means what? 3. Okay, so 3 phosphates. A phosphate is PO4. Okay? Meaning that the molecule consists of 1 phosphorus and 4 of those. Alright? So we got them linked up. Alright? Now,
What did you say the 4 represents?
4 oxygens. See, these are linked in a chain. So you see it as 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. If it was by itself, it would just be PO. Okay? And how they actually look is that's a tetrahedron, right? So it would be a phosphorus here, oxygen, 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 oxygen. That's how they shape. They're little tetrahedrons. That's what phosphates look like.
Each day, we're creating content, serving the product, right? So people can't for what's happening right now. We will be the reference point for the future. When you're the first, there's nothing to double check. Right.
So as I'm speaking, don't have to get
Bang. Catch this.
Love some
or better known as Enqi.
What's that down there? Hold up. No artificial flavors. Egg free, dairy free. Just 1,000.
Gluten free. GMO free. So, same thing with
Good
the ranch.
stuff.
GMO, gluten free, egg free, dairy free, no artificial flavor. So, yes, there's a few funky things in it. Yes, there's some funky shit in it. That's fine. It's vegan though. Alright. Then we're just gonna, see what I'm saying? We're just gonna do it like that. Alright, we're gonna do it like that. And then we're gonna do it like that. Do that like that. That's done. Bam. That's done.
Phosphorus atom in the center, and it makes four corners around it that make the shape of a tetrahedron, which is a four-sided triangle. Okay, it's the basic. It's the first platonic solid. Y'all know about platonic solids? No? Wow, it's good. It's good though. It's good though. Y'all just give me more symptoms on camera. I always assume people be on stuff, so I just kind of go with it. You know what I'm saying? It's good to know. So you got tetrahedron. Okay. You got hexahedron, or better known as a cube. You got octahedron. Okay, you got icosahedron. Those are the heads of all viruses. Icosahedron. And then you got dodeca. Old dodecahedron. Dodeca means 12 because do means 2 and deca means 10. Alright? So tetra means what? Tetragrammaton. Right? Tetramer. What does tetra mean? 4. Or tetras. Hexa means what? 6. Oct. 8. Icosa. 9. 20. Yeah. And dodeca. Okay.
What's the etymology of icosa? How does that equal 20?
That's the root word. Because it's 20 faces on it. You know? Dodeca is only 12 because its shapes are larger polygons. These are more basic ones. So tetrahedron, hexahedron, octahedron, icosahedron, dodecahedron. So we talk about tetrahedron, which represents 4 triangles put together. Alright? So you put them all together. confusing. You know, see what that is, right?
Is that the base?
Yeah, see, this is one triangle, that's the side, right? That's the other side, like a pyramid. This is the bottom. That's the base. So that's one triangle, 2, 3, and then 4 on the side that you don't see. Alright, so what's so important about ATP, y'all?
Energy.
Energy. What a word. Energy, energy, energy. Now, how do you get the energy out of ATP?
Is the energy that's released?
Okay, how is it released? The turbine actually makes these. See, as the hydrogen is being fueled through, I'm going to draw that next. As the hydrogen is getting fueled through and it's spinning like a turbine, it's the mechanics that it does is just starts putting adenine, it starts putting AMP with 2 phosphates or putting ADP with 1 phosphate. It just adds phosphates on to this part. Okay, it just keeps adding phosphates onto this, growing it out, and then releasing it in the matrix of the mitochondria so that your body can use it. Okay, but you were saying it's for energy, and you mentioned energy release. How is the energy released though? What is the process that occurs that releases energy by the books? What do the scientists say? What do the books say?
Phosphate breaks off. One of the phosphate breaks
One of the
off.
phosphates break off. So this one is an alpha phosphate group, right? That's beta phosphate group, and this is gamma right here, okay? So they say that the most powerful energy in ATP exists between beta and gamma, right in here. They say that's where all the energy is. So they say cleave off and rip off one of them phosphates, energies will bow, and you're able to use that energy to drive functions. Now that's what all the books say, but I find it to be something a little different. All right? And actually what happens is what really happens is both of these get cleaved off. All right? And that gets left. So if I take 2 phosphates off of ATP, what am I left with? A what, P? A what?
Monophosphate.
If I take 2. That's if I take 1. Because if I take 1 away, it'll go from tri to di. If I take 2, it goes from tri to mono, AMP. Alright? So amps. Not amps. I'm just playing. I want y'all to write that down. Oh, that's what amps is though. Alright, so this right here is called pyrophosphate.
Dress it up. Oh, yes, sir. Yes, sir. I posted that. The reason I made those because I made one for me the other day. Me and my partner here just on a workout. We come work out. We eat after. I put it on Instagram. People went crazy. So I was like, okay.
Needs to know what that
What
is.
Excuse me.
Yes.
I had a question. So when you fast, does your body go through that same process of the
Are you still making ATP?
Like, are you still, is the energy still being released from the phosphate breaking off?
Oh yeah, this is a function no matter what's going on. This is constant.
Because I felt like when you fast, then when your body kicks in the ketosis,
kicks in. Oh, ketosis. Yeah, ketosis is when you burning, you dealing with fats, beta oxidation. Yeah, but beta oxidation, what are you producing? You're still producing ATP.
Yeah, I
See,
think
when you use
fat
sugar,
produces like more of it.
Yeah, it's just more.
Versus sugar.
Sugar, you only yield 36 ATP. Fat, you yield 147. So you make way more ATP off of fats than you do off of glucose, and that's because fats have way more carbons in their chain. For instance, DHA is called DHA because it's docosahexaenoic acid. That means that it has 20 carbons. That's a lot. Glucose don't got 20 carbons. Glucose got 6 carbons. You see what I mean? So you can end up breaking that DHA down to a lot more than you can with glucose. That's how you get more energy out of it.
So regardless of what your body wants that process.
Oh yeah, yeah. And that makes more sense in places like Detroit in the winter, where the sugar makes more sense in like the Caribbean and in the equator. Because down there, the carbohydrates and all that, you can break those sugars down and use that for your energy source a lot more efficiently than you can up in areas where it's winter and it's cold and no vitamin D and all that stuff like that. You know. All right, so is that a good?
Oh, yeah.
Good. Okay.
Yeah.
Sometimes I move forward without actually finishing, so I want to make sure. Pyrophosphate is what it's called when you got two phosphate groups bonded together. Now, this right here is very, very special. Pyrophosphate. Keep that in mind. We're going to come back to pyrophosphate. Y'all got all that? I hope this is coming off the board. What? Oh no, she didn't disinfect you, did she?
What?
You got disinfected?
Man, is it vegan?
Vegan, I'm not about that. I don't eat meat.
I
don't.
but I just wasn't sure.
That's crazy.
No, you did the right thing. You gotta ask everybody. These days, you can't assume nothing. I be asking people, yo, is there any dairy in here? They be like, no, just milk. Did you hear what I just asked you? Did you just want to? Okay. Yeah, I can't trust nobody, man. I ask people 10, 15, 11 times. They be mad. I be like, look, you want a good tip? Just give me shit, man. Okay? I'm not eating that stuff. You know? And then me, I still have this this problem where I classify eggs as dairy too. Now, I think all that stuff is the same thing. I be like, milk, cheese, eggs, that's dairy. But it's not. Eggs ain't dairy. So if it say dairy free, it can still have eggs in there. You know what I'm saying? You're like, eggs ain't dairy. Dairy deals with milk and cow. And I'm like, okay, it's dairy to me. You know what I'm saying? I consider it dairy too.